One thing that you might have noticed in the previous readings is that there aren't as many properties for subtraction and division as there are for multiplication and addition. So why is that? Well, part of the reason has to do with integers and fractions. Remember what integers are. We talked about this in one of the earlier videos for classes. These are positive and negative and whole numbers and zero. Well, how do we get a negative whole number? That comes from the inequities between adding and subtracting. So if we look at, for say, the commutative property, if we have 3 plus 8, that's equal to 8 plus 3. That grouping really doesn't matter. But if we replace this with subtraction and say 3 minus 8, and we compare that to 8 minus 3, there's an equity here. They're not going to be the same. 3 minus 8 is going to give me our negative 5, and 8 minus 3 gives me a positive 5. The same thing happens, though, when we look at multiplication and division. That's where we get our fractions from. If we look at 3 times 8, well, that will be the same as 8 times 3. But if we flip these signs around, we get 3 divided by 8, but that's not the same as 8 divided by 3. So the biggest takeaway here is with adding and multiplying, order doesn't matter. But that order doesn't matter if that's the only operation that we have. Okay, division and subtraction, we definitely have to be paying attention to that. For the inverse and identity properties of both division and subtraction, they're embedded into addition and multiplication properties. It doesn't seem like it, but they are. If it wasn't for our properties of addition and multiplication, we wouldn't have these things arising. Let's start with the additive identity property. You might not remember what this is. This tells me that any number plus 0 is equal to any number. So any number, that includes the entire range of numbers. This could be a irrational number, and this works. It could be an imaginary number, and this works. That means it could also be an integer, like -4, and still work. Okay, so we're adding a negative there. But can I turn this into subtraction? And the answer is yes. Because this is an addition sign, I can flip these. 0 plus -4 equals -4. But if I take this one step further, I can get rid of the addition sign and just leave the -4. And now I have subtraction. So here we go from addition to subtraction, just by manipulating where those are placed at. The same goes for the multiplicative inverse property. So if I have 4 times 1 over 4 equals 1, if I rearrange this, I can get one version of the division identity property. All I have to do is keep this, switch the sign, and flip this one. 4 divided by 4 gives me 1. This is the very first version of the division identity property. Any number divided by itself is equal to 1. That originates from and is derived from this property here.